and welcome back to Reinforcement Talking. My name is Maria and I will be your host. Today we would like to welcome a very special guest and prominent researcher, Dr. Aidan O'Sullivan. Hello.
Hi.
Aidan is an associate professor in energy and artificial intelligence at UCL Energy Institute and a Turing Fellow at the Alan Turing Institute, the UK's leading centre for AI and data science research. He's also the founding course director of the Energy Systems and Data Analytics, an innovative master's program that combines the study of energy systems and sustainability with data science and machine learning. Aidan is also a co-founder and STO of Carbon Re, a spin-out from UCL and Cambridge University, focused on reducing carbon emissions by gigatons by using AI to improve the efficiency of energy-intensive material manufacture, cement, steel, and glass. And a quick introduction to what we will be discussing today. AI has plenty of applications that could help tackle climate change. Efficient operation of electrical systems, transportation, building green cities, CO2 removal, climate prediction, and many other areas are currently at the frontiers of environmental and climate AI research. Potential of AI in electrical power systems is very important. AI techniques enable us to cut energy waste, lower costs, and accelerate the use of clean renewable energy sources in power grids globally, along with improving the control and operation of power systems. Could you tell us a bit more about your current research interests and what has motivated you to pursue it, coming from a mathematical and engineering background?
Sure, be very happy to tell you about that. And yeah, thank you very much for the invite onto the podcast. Really great initiative and happy to be supporting. So in terms of my current research interests and what kind of motivated me to get into them, in terms of my background, I'm kind of an electrical engineer, but I've wandered around the engineering sphere for a bit. So I've done bioengineering, which was part of a mechanical engineering program, and I've been in a civil engineering department at MIT and also worked on transport systems there as well, and also worked in aviation. So I've kind of moved around in lots of different research projects, and the overall or the kind of unifying thread would always be quantitative analysis. And if you have a mathematical background or an engineering background, you're usually welcome on a lot of research projects and able to get involved in anywhere you're interested in, because you always need somebody on the project to work with data and to drive the methodological kind of research angles. So that's been a core kind of element of my kind of research career, is just being involved in projects that I'm interested in and bringing a quantitative element towards them. Kind of joining UCL as a faculty member, I was able to set my own research direction a bit more and focus on areas that I was really interested in. And of course, being an electrical engineer, the power grid is something that I'm very curious about and very interested in. And what's kind of, when you couple that with the artificial intelligence kind of research background and exposure to deep neural networks and reinforcement learning and kind of a control theory background as well, one thing that kind of strikes or jumps out is this idea that kind of is core to my research around, if you were to redesign the systems that we use to support modern society now, they would look very different to what we actually have. So a lot of the infrastructure that we have is a legacy of decisions that were made 20, 30 years ago. The grid especially is very much a case in point of this, because it takes us so long to expand or build critical infrastructure like this, which, you know, there are arguments for why that's a very good thing, but there are also arguments for why that's a very bad thing, and we should be able to move quicker and do more. But fundamentally, the way we operate the infrastructure, there's kind of this, I think it's Le Corbusier or architectural kind of saying of function follows form follows function. So these things all interact. So the form of the grid is very much determined by how we use it. And the way we use it is also influenced by very much the form of it. So we're constantly in this loop of operational decisions are limited by the structure of the infrastructure. And if you were to then look at what you can do in terms of operational capabilities, now that you have AI, that's where I find very interesting. So how can you re-look at these processes, whether that's steel manufacture, cement manufacture, or how you operate the power grid, now that we have made much more advances in AI?
In what ways could AI help tackle climate change, and how this energy systems could kind of contribute to global reduction of carbon emission? And also, what is the most promising, in your opinion, direction at the moment?
Sure. So I get asked this question quite a bit. And in some sense, I don't want to give an answer because, the applications of AI are only limited by your imagination. So wherever people who understand AI think they can deploy it to solve a problem in the right domain, that can be something that moves the needle significantly on climate change. Now, if you were to kind of, that's obviously, me getting out of answering the question and being evasive a bit, but if you want to look at where AI can have the most impact, then you should be looking at where are the most emissions coming from. So obviously the power sector, which generates our energy, is really at the forefront of decarbonization. So anywhere that you can get 2 or 3% improvements in power systems, you get huge savings because of the just sheer scale of the system. So if you improve the transmission of electricity efficiency by 2 or 3%, that results in terawatt hours of reduced or extra energy or reduced emissions translated into that. So you need to generate less if you can transport more efficiently. Now, there are ways to do that using the existing infrastructure. You can do things, for example, you can make better usage of capacity, and that's often what AI is really doing because it's a software technology. So you're not building new hardware, you're trying to get more out of the existing infrastructure. So an example of that would be dynamic thermal line ratings, which is a project that's some researchers in France are looking at. And the underlying issue there is that the grid is capable of, to go back to first principles, the limits on how much energy you can move through a wire is a function of the temperature and a function of the environmental conditions of the wire. It's not static. But the way we set up the grid, we have fixed line ratings. We say we'll never pass more power through here. And often that bottlenecks us. So often we have renewable generation, which is unable to reach center points of demand because of limits on the actual infrastructure. But if we make those limits more dynamic, we can make better usage of that resource to move power more efficiently. But that requires continuous monitoring of the state of the wire, of the state of the grid, and also the environmental conditions, and also some way to estimate what the actual capacity is without running the risk of actually breaking that connection by overloading it. So that would be one kind of practical example of something that is ongoing research right now that scaled globally would have significant impact on how we run our grids and how we do things immediately. Another area that I would say is something quite practical that people could even start working on now, and that I know there are some companies looking at, is predictive maintenance for wind turbines. So again, renewable generation is a core part of decarbonizing the power system, and we obviously need to build a lot more renewable generation in order to get rid of coal generation. And a fundamental technology as part of that is wind power and solar power. Those are the two dominant technologies in the space around that. So as much as we can build, we also have to learn how to operate this new kind of technology. And that's what's really exciting about the energy transition that we're going through. While it is being, if you focus on the positives, it's a very impressive transition that we're going through in an engineering scale of how much the system is going to change in such a short time. The negative, of course, is why we're doing that. We're doing that because it's a critical emergency, and we have to do that in order to mitigate climate change. But as a kind of engineering problem, it's very exciting and very interesting that we've added so much new technology into the system, and now we have to learn how to operate it properly. And operating it properly involves doing things that we haven't done before with coal power plants. For example, maintenance on a coal power plant is very, very limited. However, if you put offshore wind farms, in the north of Scotland, maintenance becomes a real issue as you kind of break down more frequently. You have to schedule people to go out. It takes time, and you lose what's called availability factor. So how often when power could have been generated was your wind turbine generating power? And at the moment, we're operating at around 89% for kind of modern wind farm fleets, offshore wind farm fleets. And predictive maintenance through AI can help bring that up to 98%, 95%, which in essence is like adding 10% more renewable generation into the mix. So that's an example of a really hard AI problem. You have to try and understand all the potential causes of a breakdown or a failure in a wind turbine, the gearbox, the bearings, the blades, what's going to crack under what conditions, how far in advance can you spot that? Can you spot that 2 weeks in advance? Can you spot that a month in advance? If you can, the further out you spot it, the more predictive maintenance you can do, the more time you have to go out and fix it without encountering as much downtime. So getting more out of existing infrastructure is really critical to trying to reduce emissions as quickly as possible. In the long term, we obviously have to build more and redo the whole system. But in the short term, it's very important to lower emissions by as much as possible, because again, 1 ton of carbon saved now is equivalent to 2 tons in 10 years, just because of the long life effects of these technologies. So AI has a really critical role in trying to get as much out of existing infrastructure as possible. And the limit as to what that can be is defined by your imagination and your understanding of the problem. It does require multidisciplinarity. So people do need to understand the problems, get very invested in them, and go out and solve those problems. So it's not a case of you can just take a team of machine learning engineers and throw them at a problem and it'll be solved. You really have to do multidisciplinary research, involve a broad set of teams, people who are engineers, people who are biologists and things like this, and start to really get a good grasp of the problem so that you can then deploy what are kind of well understood solutions in an optimal way.
So in your recent work, you have mentioned a model that basically tracks the impact of the increased renewables use on baseload energy generation, minimal energy that the power plant has to produce of thermal plants. So, and I know that you track it from 2009 to 2017. So how do you account for sudden disruptions in the war, for example, like war in Ukraine, where renewables are being more in demand right now?
Sure. Yeah, I think you're referring to a really good PhD student's work of mine. So Patrick, so he would have led that research. And again, what we were trying to do is look at the impact of renewables on the operation of existing infrastructure. So while we know they kind of push some generators out of the market, they also change the way they're operated. So again, the system is defined by kind of the form and the function at the same time. As much as we have these things here, and they might sell electricity at, say, $30 per megawatt hour. That might be the market clearing price at which a generator can then say, oh, look, we're quite profitable. We are able to sell this. But the reality is renewables change how they operate quite significantly. So what we were looking at was the impact on operational schedules. So what you really want is a nice flat profile where you're always generating the same amount of energy. However, renewables add a level of stochasticity into the system, and that makes it much more important to be predictive, be able to kind of make good forecasts, and then to schedule generation appropriately. So what overall we were trying to show with that was the idea that the change in operation of that infrastructure actually makes it far less profitable than it would appear just based on prices. So while it looks like this is a great investment at $30 per megawatt hour, the reality is you're operating it in a very unusual way because of the impact of renewables. So what this means is that you might have more predictive maintenance, you might have more failures, you might have to do a lot more operational work to keep that system up, and you might end up that it's actually not profitable for you to keep that infrastructure going. So as much as we wanted to look at the trend in kind of critical infrastructure in generation, so for example, taking things into account like Ukrainian war and things like this, what we were really focused on was how much renewables are impacting it. And while you can kind of account for things like changes in the market and changes in the price overall, the impact of renewables is still felt because it kind of lifts both together. So while the price of energy goes up in that sense, what we were really looking at is when renewable generation comes online, it tends to be what we call marginal generation. So the cost of 1 extra megawatt of wind power is zero. It's already generating what it's going to generate. You don't have to add any more fuel. And this is the big difference with, say coal power or gas power, is that every megawatt costs you a bit more. And that's the big difference in terms of how we operate those things. So while externalities like temperature and externalities like wars did affect the market, during that time, overall the effect of renewables was, something that had to be taken into account in a different way. And while it wouldn't have been affected directly by those, they would have affected the market overall.
There's a lot of things to account for. I just want to talk a bit about your startup, Carbon Red, that has developed Delta Zero software, which uses deep reinforcement learning agents that can adapt to specific plant requirements to minimize the cost and emissions of plants that produce cements and fuels. Could you please tell a little bit more about it, how you came up with the idea, and what are your long-term ambitions for the company?
Oh, wow. Might be good to break that up a bit. So in terms of how we got started and what we were kind of doing in terms of AI, it might help to give a bit of context for cement plants and how they operate. So Cement is the second most consumed product in the world after water. So again, we need a lot of cement to make cities, to make our roads, to make our homes. And as a part of that, there's associated emissions with that. So it's an incredibly carbon intensive process, because in order to generate the raw materials for cement, you need to expose limestone and clay and some other kind of chemicals to really high grade temperatures to bring out the chemical reactions needed to make that material. And traditionally, these have been referred to as the hard to abate sectors, where there's no path to decarbonisation that is really attractive. With transport and with the power system, we know what we want to do. We want to replace coal powers with lots and lots of renewables, and we want to then electrify transport through electric vehicles. However, when you need temperatures of 1500 degrees, it's very hard to think of a viable pathway. Things like gas are actually worse. So while we replace coal power with gas generation, in cement, the gas reaction would actually lead to levels of nitrous oxide that would be toxic and poisonous. So we can't replace it that way. So it's not being considered as a viable technology. So what we wanted to do at Carbon Re was essentially form a startup that, if it was successful, would have major impact on carbon emissions. We'd kind of seen lots of climate tech startups that were looking at offsets, we're looking at financial mechanisms, and we're looking at kind of monitoring from space where emissions are happening. And even if those were really successful, it wouldn't have made a huge difference to where we were kind of going to go. So that was the ambition, to form a company that, if it was really successful, would make a big difference. Now, how we got started, quite a long story with lots of missteps and mistakes along the way. But overall, what we essentially identified was that there's variability in the process from day to day in terms of how much energy gets consumed. And this variability doesn't make sense. It can't be accounted for through changes that are happening in the plant. It's a very slow process. And what it really comes down to is kind of changes in operator decisions and things like this. So as much as we wanted to understand the process and then move forward with the product, what we realized was there was this opportunity to try and bring every, say, bad day's performance down to a good day, and the effect of this on carbon emissions would be really significant. So that was the kind of genesis of the project. So again, based on research that my co-founder Dan was doing at Cambridge at the Institute for Manufacturing, where he did a survey of kind of 3 cement plants to understand what was happening there in terms of kind of their energy consumption from day to day and decisions they were making. And what we kind of realized was they needed to be a product that helped operators make better decisions in the moment. You're essentially solving a stochastic optimization problem. So you want to make X amount of cement, you need X amount of raw materials, and then how much fuel do you need to get all that material up to the right temperature to bring about the reactions. Now, if you are also changing the quality of the fuel you're putting in, the type of fuel and the type of raw material that's going in, every day something is kind of changing that you have to adjust for. So yesterday's optimal decision is not tomorrow's optimal decision. So you have to solve that optimization in real time. And in order to do that, we had to build kind of optimization algorithms, predictive algorithms, all behind what we consider an online dashboard that operators can then log into and then get a sense of what they should be doing.
On a global scale, how adapted this startup is at the moment? Like, how many different plants that produce cement and fuels are utilizing this technology at the moment? And is the scaling kind of a problem, or is it going smoothly as you expected?
Oh, it's all going smoothly and perfectly the plan, of course. So great question. So there's about 3,000 cement plants in the world. 1,500 of those are in China. And globally, cement is about 8% of global emissions. So again, 3,000 cement plants are responsible for 8% emissions. If you look at how many cars that is or how many power plants, you'd have to scale to, orders of magnitude more to make the same kind of impact. So that's why we're really interested in this industry. It's a real concentrated source of emissions. And we kind of feel like it's easier to, reduce emissions at one cement plant than it is to take, 500,000 cars off the road and electrify them. It should be much quicker to do this. In terms of where we're at currently, so we ran a successful trial. In terms of kind of the story of Carbon Re, I guess it's probably helpful to talk about the funding rounds and the progress as part of talking about where we're at in terms of plants. So we initially got set up in October 2020. we kind of did some prototyping and worked with some plants and got some ideas around what we wanted to do, and then did a kind of pre-seed raise that gave us the funding to then go and do a trial in a cement plant in India, which was a very early version of the product. And any advice I would give to kind of AI students who wanted to, do a product or build something is very much just build whatever you can and then push it out to as many people as you can, and just get it out there rather than kind of build something perfect in your own time. So while we pushed out something that wasn't as good as it could have been, it helped us get a sense of what that needed to look like. So we ran one trial with the plant in India, and that lasted for about 3 or 4 months, and we were able to show a reduction in energy consumption of about 10% during that trial period. We encountered lots and lots of challenges along the way that involved me getting up at like 5 a.m. to talk to people on Indian time about why our system had gone down or things like this. So, and really great work from the team in terms of supporting over the weekend, and it being really challenging and really kind of, early day startup kind of stuff. But really fun to do as well, and really rewarding in terms of what we got out of it. So that let us then go on and do another raise, which has given us the finances and kind of the ability to build out the team, which is now enabling us to do another set of trials with 3 other cement plants around the world. So in Spain, Vietnam, Brazil, all over the world globally. And this is kind of the first stage before we kind of start to scale even more aggressively. So we're demonstrating this again and then looking to build further kind of trials or engagements as we go throughout the rest of the year. So not all going smoothly, of course, like lots of challenges along the way, but definitely going quite well in terms of where we are with the technology and where we are with the kind of customer interest.
I see. So there's a lot of trial and error.
Absolutely, yeah. Like again, things break in production that work locally and all this kind of fun stuff, and you're always kind of learning more about the problem and finding out that there's some aspect you didn't consider that you then have to build into the technology to make sure it's accounted for again. But again, it's very much worthwhile just putting stuff out there and getting going with something rather than trying to solve the whole thing and then step forward. It would take you too long to kind of work that way.
So, in your opinion, is it possible for AI to accelerate the access of humans worldwide to clean energy and reach net zero by claimed 2050 deadline?
Well, it's necessary. So I think it's if you look at technologies and the potential that they have, AI is a really powerful enabling technology that can kind of distribute across any kind of industry. So you can use it in transport, you can use it in power generation, you can use it in kind of protein folding, you can use it anywhere. So it doesn't have to be limited to just where it's being used right now, which is kind of some of the frustration I have with the community, is that people are doing kind of AI for finance and things like this, and really focusing on using it to predict hedge funds when there's so many bigger problems that we should be solving first. So in that sense, it's really great to have people talking about this area and talking about what can be done. I think it's essential that we build in more work around this, and as a computer science / maths kind of driven area, maybe it's been a bit too focused on things that we can do, and sometimes we need to break out of that cycle a little bit. So again, as much as large language models are getting a lot of focus right now, that's also because we've been working on them for a long time. We kind of have a built up kind of reservoir of things that we know we can do, and we can show progress, and it's kind of rewarding to be able to interact with a chatting agent. What's not really happening is fundamental research into some of the core problems for net zero. There's a lot more work needed around, say, AI for power systems. We tried to drive some of that with the Learning to Run a Power Network Challenge, which was kind of emulating the Learning to Walk Challenge in kind of reinforcement learning at NeurIPS. So again, initiatives like that really help push things forward and set a benchmark. But I think overall, there are challenges in that you have to have an interdisciplinary team to solve some of these problems, but there does need to be much more efforts by the kind of AI community to engage with these problems overall, rather than just kind of focusing on what we know we can solve or what kind of are the classical problems. So to be a bit more creative and to be a bit more focused on, say, sustainability or things that are having an impact is something that I'd like to see with the AI community. But as it matures, you are seeing a bit more of that, which is nice.
Yeah, I've read in one of the articles that this year focus will be given more to different startups and like small companies, since they focus on things that usually big companies don't give funding to. Governments give funding to. So yeah, I feel like it's a very good start and very good initiative.
Yeah, absolutely. And I mean, you might see something like, Google say they're going to put £1 million into net zero research for AI, but we're putting our entire company into AI research for net zero. So obviously it's a much more bigger focus. Even if the amount of money isn't the same, the focus is really a big deal in terms of how well a company does. So that's the advantage that startups have, is they tend to be much more focused on what they're doing and trying to solve that particular problem. Whereas as you get to a big company, you get more distributed, you get less kind of focus on the actual problems you're trying to solve. So in terms of as a space, what's kind of happening, that's really important. And I think there's some kind of, again, there's something that I really dislike in the community of, like, guys like big AI people popping up at Facebook and Netflix and places like this. That's a little bit of a negative for society if AI talent is being hoarded by what are essentially media companies that are focused on improving the click-through rate of advertising. It's not good for people with really well developed skills from academia and university who've studied really long time to go off and apply those to kind of what I would consider trivial problems that have very little significance in the real world, or actively doing negative in some cases. So more kind of focus on solving real problems using AI is something that the community probably should be looking at overall. And it doesn't help that some of the leading stars are at kind of those kind of companies, but I think there is a bit of a change in terms of focus, and some of the work coming from those places is really good, but again, the application isn't really aligned with what's good for society overall.
Yeah, I completely agree. I think that was all on my part. Oh, wow. If there's anything you would like to also say or mention, maybe to younger generation, on how to start, how to get into this field, how to build your own startup, maybe some tips and.
Well, I'm not sure I'm really qualified to give too many tips. But I guess, the advice I would give as someone who runs a master's as well, and has had the privilege of working with 200 students in the space over the last 5 years, is to, you're good enough. Like, take whatever you want to do, just go and try and do it. Don't worry about the fact that you don't know Java as well as you should know Java, or you don't know C++. Definitely just go out and play with things and look to solve problems and put your work out there. And I think the best skill you can have is to be easy to work with. That's not always the case in the AI community, for sure. So if you're easy to work with and you put your work out there, you'll get lots of feedback, and hopefully find like-minded people to go off and do the same kind of projects and engage with, and improve in terms of where you're at, and improve in terms of impact, hopefully. But just put your stuff out there, I think.
Great. Thank you so much.
Pleasure.
It was nice having you on our podcast. Tune in to Reinforcement Talking, and we'll be back with the next episode next week.